Hi everyone, welcome back to Mind Maths with Amna. Today I'm going to solve question 1 which was given in the final exam. A massive majority wasn't able to solve this question, so I'll be making a video over this about the solution. Okay, so we need to find the reduced form equations for output and the price level. Equation 1 is output is equals to beta price at time t minus expected level of price plus an error term. In order to get the reduced form of output, I will have to eliminate this from the equation. Okay, so this is equation 1. I need to replace pt minus expected value of pt from equation 1. Okay, so the first step should be that we should put equation 3, which is the monetary policy rule, into equation 2. So put 3 in 2, you'll get output is equals to m bar minus delta pt minus n yt minus alpha pt. Okay, so we have 1 minus n into yt is equals to a m bar minus alpha plus delta pt. Okay, so basically alpha plus delta pt is equals to m bar minus 1 plus n yt. We can call this our equation 4. Okay, so you can take expectations conditioned on time t minus 1. So take expectations conditioned on time t minus 1. Okay, so then we'll get an alpha plus delta expected value of price minus m bar minus 1 plus n expected value of yt, and we can call this equation number 5. So I want to basically subtract equation 5 from equation 4. So we can write these again. Okay, and I want to subtract them, so the sign gets reversed, the plus becomes a minus. This cancels out, so monetary policy goes away. We have alpha plus delta pt minus expected value of pt, and then we have 1 plus n expected value of yt minus yt. Okay, so if we make the difference in the actual price and the expected, we have 1 plus n over alpha plus delta into this. Okay, so now we need to put this in equation 1. So we can just label this as equation 6 and give the instructions that put 6 into equation 1. So what was equation 1? This was equation 1. Okay, let's go ahead. We have a beta 1 plus n over alpha plus delta, and then we have this plus the error term. Let's take a common denominator. Oops, yt minus yt plus alpha plus this into ut over and 1. Okay. Then we have we had a y on the left side, and we have a y here as well. Okay, so what we can do is let's just cross multiply first to get alpha plus delta into y, and this expression will remain the same. And now we can make y the subject. Okay, then we'll get plus beta 1 plus n to yt, and then we have beta 1 plus n into the expected value of yt plus alpha plus delta into ut. Okay, so therefore when we make yt the subject, we'll end up with the structural reduced form of output. So let's write that down. Oops. Beta 1 plus n into the expected value of income plus alpha plus delta over beta 1 plus n into ut. So basically this right here is known as the structural reduced form of y. We need to remove the expected value of y in order to find the reduced form of y in terms of just parameters, exogenous variables, and known constants. So how we can do is this is by take the expected value conditional on time t minus 1 of the above equation. So what we'll have then is, if I just look at this equation, they're the same. So if I take expected value, I'll get expected value over here, and expected value of the error term, right? And then we have alpha plus delta expected value of output, because we can take this as common, and when this goes there, this will cancel out, and this will be equals to alpha plus delta expected value of the error term. And since the expected value of the error is conditioned on the previous time period, we can say that it's going to be a 0. Okay, hence the reduced form of output is just this. Actually, that becomes a 0. So if this thing is equals to a 0, then our final answer is alpha plus delta over alpha plus delta plus beta 1 plus n into ut. Okay, the question actually asked us for the variance of y, the change in y because of a change in money supply, and a change in output because of a change in the error term. We can find that from over here because this is the final reduced form. You cannot find the multipliers unless you find the reduced form. All of you besides one student was able to understand this, because all of you didn't get the reduced form correctly, so the multipliers were calculated incorrectly. So the change in output because of a change in money supply is 0 due to the neutrality of money. Okay. The only change in output when agents have rational expectations are due to the error term. You can see this is the change in output which will be there because of a change in the error. And the variance of output is simply, this is just a number, right? So we're going to square this and we're going to have the variance of the error. So variance of output depends on the variance of the error term. Now we need to find the reduced form equation of the price. We already had equation, where is it? Price in terms of, yeah, over here. So from equation 4, we can easily just substitute our answer over here. So let's find the reduced form of PT. Okay, what's up? Okay, so we're going to look at equation 4, and now that we have the answer for income, we're just going to substitute this answer. Just going to substitute the reduced form over here, and then we're just going to make PT the subject. We're going to get a m bar over alpha plus delta minus, over here this is when I'm going to divide by, that's going to cancel out, right? So we'll have a 1 plus n over alpha plus delta plus beta 1 plus n into ut. Now this is the reduced form of price because it is in terms of exogenous variables and parameters. Okay, so this is the reduced form. Once you've gotten the reduced form, now you can get the multipliers. Okay, so what is the change in price because of a change in money supply? We know a rise in money supply should be inflationary, so this is a positive number, right? The actually error also take what about a change in price after a change in a positive shock, demand shock? This leads to a negative relationship. Okay, so I think that's all the question asked for. Okay, this is just method 1. The question actually asked us to assume a appropriate trial solution and then solve for it, but I still wanted to make a video in which method 1, which is our usual way of solving rational expectations, is also covered. However, I will add method 2 in this video, and it's called the trial solution method, and it's fairly simple. Actually, it's probably easier than the first usual method. Okay, we know that the trial solution is a method in which we just guess the correct functional form of yt and pt, and we just verified it. Okay, because we know that yt is a real variable, therefore I know that the only thing yt is basically just going to depend on the error term, and I know that the price is actually a nominal variable and it will get impacted by anticipated policy and as well as shocks. Okay, so it has to be dependent on the money supply and also errors. Okay, so what can I have as trial solutions? So my trial or basically guess solutions can be as follows. I can say that output is basically related to the error, and I'll obviously need to find the constant A. And I can say that the price is related, depends on monetary policy, where the B is just a constant, and C into UT, where C is also a constant, and I need to find B and C. Once I find B and C, then I'll have, I can just plug these values over here and I'll get the reduced form of output and price. Okay, so let's see. The first equation that we had given in the question was, this was the first equation. Okay, so let's substitute in the trial solution. In the first equation, we'll get an A ut is equals to beta, bracket open, bm bar plus c ut minus bm bar minus c expected value of ut, which we know equals to 0, plus ut. Okay, this and this cancels out, and we know that this equals to a 0. So therefore AUT is going to be beta CUT plus a UT, and therefore UT, basically you can take it, cancel it out, you'll get the first equation, beta C plus a 1. So this is equation number 1. Okay, equation number 2 will be as follows. Remember, we put equation 3 in 2 and we obtained this equation. Yeah, so we can now put the trial solutions in both of these. So we'll get a 1 plus n into a ut plus m bar minus alpha plus delta, and b's was, what was it, over here. Okay, let's open this up. I'll get a 1 plus n into a ut is equals to m bar minus and alpha plus, actually what we should do is I should just say 1 minus b alpha plus delta, and I can take m bar here, and then I'll get, and the minus stays, alpha plus delta into c uc. Okay, now if we compare coefficients, we have to compare coefficients in this case because ut doesn't cancel out because there isn't any ut over here. Okay, so what we can see is that the coefficient of ut over here is this, and over here it's this. So we're just going to equal them to each other, and there's no constant on the left hand side, so that means 0 is equals to 1 minus b alpha plus delta, and we got the value of b over here. So that was fast, like this was actually a plus because that goes there. Okay, now that we found the solution for b, we need the solutions for a and c. Okay, so let's make c the subject because I've already made a the subject here. So c will be equals to a minus 1 plus n over an alpha plus delta into an a. Okay, and we know that, I'm just going to actually highlight this is the value of a. I'm going to put this into this. Okay, so basically I'm solving these two equations simultaneously. So I had a is equals to beta c plus 1, so I'll have a minus beta 1 plus n over alpha plus delta a plus 1. I can make a into the subject. I'll get a 1 plus beta 1 plus n over alpha plus delta is equals to a 1. Okay, I can take a common denominator and then I can cross multiply. So when I cross multiply, I'll get a 1 multiplied by alpha plus delta. Okay, so a is going to be an alpha plus delta over an alpha plus delta plus b 1 plus n. Therefore, so this is the final value of a, so I can make a box around it. The value of c was dependent on the value of a, and now that we have the value of a, we can very easily find the value of c, which is a 1 plus n over an alpha plus delta into this expression. So as you can see, alpha plus delta will just get cancelled out, and the value of c will be a minus 1 plus n over alpha plus delta beta 1 plus n. Okay, so now that we found these unknown constants, all we need to do is substitute it into our trial solutions and we have our final answer. So let's write down the reduced form. For the reduced form of each, the reduced form, okay. The value of a is, where is it? Over here. Okay. This is actually going to give you the exact same answers as we got from the first method. So it is actually the same thing. Okay, the answer for b was a 1 over, okay, so m bar over alpha plus delta, and the value of c is this. Okay, which means we don't need a positive sign here. Oh, sorry. I'm just going to delete that. Okay, and then we have a ut. So this is the same solution as we got from the first method. So I hope this video was beneficial. I think both the solutions are okay. They're both easy, but I've seen students make a lot of algebraic errors in method 1. So I would actually suggest you to stick with the trial solution method, because I think the chances of making an algebraic error would be definitely less in this method. Okay, and that's enough for today, and I'll see you in the next one. Take care.